This is the third question of the same descriptor. You can see here it's 5.32. Let's analyze the question. Actually, you have an example question in the textbook which we have discussed in class. You can refer to that for the picture. I hope they will give you a diagram also for this. How to approach these type of questions, let's see. So, you can pause the video, read the question. It says, a father pulls his son whose mass is 25 kg and who is sitting on a swing with ropes of length is 3 meters. So mass is given 25 kg. Length of the rope is 3 meters. Backward, under the rope makes an angle of 33.6 degrees with respect to the vertical. So with respect to the vertical is this angle. If they give you with respect to the horizontal, then it should be this angle. So he then releases his son from rest. What's the speed of the son at the bottom of the swinging motion? So the speed at this point is asked, right? So he swings from this raised position and he comes to the midpoint and they want to know the speed at this point. All right. So it's like you can look at the situation here, and if you're thinking about the formula for speed, you might be thinking we need to know the displacement, we need to know the time or acceleration. So none of that is given to you. So here we know that the energy conservation can be used. Okay, that's a hint here. We are going to use the concept of energy conservation. What is that? So we have the energy when it is raised at this point, we know that it contains or it possesses GPE, right? Gravitational potential energy that gets converted to kinetic energy, and the kinetic energy in the middle will be equal to the maximum, and then it keeps decreasing in the opposite direction. So you have GPE max here, you have kinetic energy maximum here, and then again GPE maximum here, provided it's an isolated system and there is no energy loss. So since we know the mass is given, so probably the GPE to kinetic energy conversion, the work energy theorem could be applied here. All right. So the kinetic energy maximum formula will be what? Half mv maximum square, right? Kinetic energy maximum will be half mv max square, and they want you to find out this particular speed. The maximum speed is what is the question. So if we know the mass, if you know the kinetic energy, then we can find out. But do we know the kinetic energy maximum here? We do not know, but we can equate it to the gravitational potential energy. Okay, that's what I meant by energy conservation. So GPE maximum will be equal to kinetic energy maximum, or you can also write the mechanical energy at point, the maximum point will be equal to mechanical energy at the rest position. Okay, this is the peak position. So both of these concepts can be applied. So what will be the formula here? Mass times gravity times height equals half times mass times v max square. So mass gets cancelled, so you have the formula. If you rearrange this, we get v max equals square root of 2gh. In fact, you can keep this formula in mind. You can apply this formula wherever you have the total GPE getting converted to complete kinetic energy. The same equation you will get even for a falling object just before it hits the floor. Again, if there is no energy loss, the speed, maximum speed, can be used for the same formula can be used there as well. All right. Now, do we have all these values in the question? We know G is 9.81, but what about the height? Now that's the tricky part here to calculate. So the vertical height, I've already drawn in the picture. It might be a little confusing. I'll draw it again. So the vertical height that the object is displaced when it is reaching this particular position is this part that is marked as h. So I need to calculate this height. Okay, so how do I calculate that? If I draw that again, so you have like a sector here, right? This is the path of the object, and you have here at the same height. I need to find this height. Now if you make a horizontal line, if you will notice that you get a right angle triangle here, right? This is a right angle triangle, this is 90 degrees, and this is the entire length, the full length up till the bottom. This is L, right? So if I find, my aim is to find this distance, say let's label it as D. So I repeat, the total length from this point up till this point is L. That's the length of the string. When it is raised to this height, this is labeled as, this is the height that is giving it the GP. We need to find that out. For that, if I find D and subtract it from L, I will get this height. So if I write as a formula, D will be, H will be equal to L minus D, right? This height equals the total length minus D. Now by applying, this is theta given. So how can I find D in terms of any of the trigonometric ratios? This is the adjacent side. So I write cosine theta equals D over L. Because we know theta, we know L, so this formula can be used to find D. So I rearrange it, I get D equals L times cosine theta, which I put it in this formula. So L minus L cosine theta will be equal to H. Now this step is a little, you'll have to think. So what did we do now? We found this height by using the quantities given in the question. The question has given you the length of the string and the angle theta. So if I find this distance, I can find H, because H is not directly given in the question. If they give you, well and good, directly you can substitute. If it is not, then you will have to use this formula. Now coming back to to find the Vmax, what do we need? We will use this formula here. So Vmax equals square root of 2 times 9.81 times, so L is how much? L is 3 and angle is 33.6. So I put this in bracket because L minus L cosine theta is H. So 3 minus 3 cosine 33.6. Okay. I write the formula again. So Vmax in this case, in this situation, is square root of mg, instead of h, it is L minus L cosine theta. This is for the simple pendulum. To find the maximum velocity at the midpoint, you can directly use this formula without having to do all this, if you can remember it. Otherwise, if they ask you to derive an equation, show this, then these are the steps. Okay, the final answer you will get it as 3.14 meters per second.